Hello, welcome to the Space Week activity, and a big shout out in particular to our STEM Roots partner schools, Sculdine Custon and Bruff, Scollida and Corbally, Roxborough National School, and St Mary's in Croon. In this activity, we're going to look at writing code that's going to be run in space on the International Space Station. Very exciting opportunity for you for your first piece of code, and it's going to be run in space, and you'll be getting a certificate to say that you have completed this achievement. So, we'll get started by looking at a few interesting facts about the International Space Station. So, the ISS is orbiting the Earth. You can see it from Earth when it's over your house. It's one of the brightest objects in the sky, along with the moon. And some amazing facts about it. It flies around the Earth every 90 minutes and it's traveling at 5 miles per second. So, in 1 second, the ISS has traveled 5 miles. That's not a problem for the astronauts inside because they're traveling at the same speed. Now, the other thing is it's quite large. It's the length of a hurling pitch. So, if the ISS was on Earth, its length alone would take up the entire length of a hurling pitch. So, it's the biggest piece of equipment humans have ever put into space. Now, on board the ISS are two Astro Pis, and what these are is these little Raspberry Pi mini computers. You may have seen them in your schools, and they are just computers that are really tiny. So you can see you've got connections for HDMI and USB, so you can plug in keyboards and mouse and screens and all that. But they also have these special pins here for connecting sensors. So there's two of these in space in special cases with a special set of sensors called the Sense Hat. And these can output messages on the screen, and they can also access sensors such as temperature, pressure, and humidity, among others. So students in this activity will learn how to make some code that runs in space. And there's a more advanced activity for secondary school students where they conduct a full project that runs over 3 hours on the space station. But for primary schools, the idea is they just want to get you into trying a bit of code and getting it running and getting it submitted. So the key dates for this is the 18th of March. So by the 18th of March, you're to have your code submitted on the online platform, which we'll look at in a few minutes. And they're going to run the code across May on the ISS. And then in June, they will be issuing certificates to students who have successfully completed the activity. So there's two links that we're going to look at. One is the link to the platform where we're actually going to write our code and submit it to the space station. And the second one is a PDF, which is just a single two-page document with details about how to do it in a step-by-step way. So you don't actually have to know any coding to do it. It's going to talk you through it step-by-step and give you the code you need to type. So here's the platform, trinket.io/mission 0. And when this opens, it has some code there already. You don't really need to understand that. That's just some code that activates the sensors, and you can leave that alone. You don't need to touch it. But the only thing is don't delete it and leave it there. And we're going to start writing our code here. I might skip a line onto line 5 to start. Now, you might get a printout of these from your teacher, or you might work in pairs and one student will have it open on their computer and the other student do the typing. But because I want to do this presentation in a speedy fashion, I'm going to actually just copy and paste the code out. So you'll see here actually on how the Trinket simulator works. It's actually got a simulated version of the Raspberry Pi here. And it simulates all the sensors. So on board the actual space station, there's a sensor for temperature. So if we wanted to adjust, because there's no real sensor here, this one simulates the sensor. So it makes the Raspberry Pi think the temperature is whatever you set it to here. And our job here is actually we have to read data from one of the sensors, which is the humidity, which is the amount of kind of water in the air. So that's the humidity sensor. And we have to actually write code that's going to read that value. And we can output it if we wish. So there's 3 requirements for the code. It has to read from the humidity sensor. It has to use the LED matrix, which is all the lights here to put out a message. And then we need to be able to run the code without any errors. So the thing is, if you're used to coding in something like Scratch, which uses blocks, this code here is a little bit trickier because it's very precise about where you put brackets and commas, etc. So, it takes a bit of getting used to because a bracket in the wrong place or bracket left out or a big S where you need a small s and your code won't work and you'll have to figure it out. And that's the challenge in it. Also, the time, your program can't take any more than 30 seconds to run. So we'll be looking at how to speed up the messages you're displaying on the screen if this is an issue. Once these 3 are met, they'll all go green, and then you can put in the classroom code. Your teacher might give you their own code, but if not, you can use mine, which is Good Car. And then you can submit your project and your certificate will be issued to you after your code has run. So let's look at getting started with what we need for the code. And the first thing is we need to get a message out on our Raspberry Pi. So the code is quite simple. It's sense.showMessage, and then you put in whatever message you want to display. So the sheet gives you this one that says Astro Pi. I'm just going to change this to Hello World. And you'll notice that if I accidentally delete one of the quotation marks, for instance, and try and run this, I get a red error saying, okay, that's an error on line 4. So I've accidentally deleted the quotation marks. I'm going to put it back in there and run it again. And now it should run happily. And you'll see the message comes out here, hello world. So that's the first part of the challenge, get a message on the screen. Now, we're going to look at a few little advanced settings that we can do on the messages. And I'm going to use this sample code here from the sheet. And this is the code to change the color. So the color system that this uses is very common in computers, and the colors are based on 3 numbers, and they go from 0 to 255, and they represent red, green, and blue. So if this number is 255, that's all the red, no green, and no blue. So this color, the text color, the writing color will be pure red, and then the background color will be no red, all the green, and none of the blue. And let's have a go and see what it looks like. And there you go, like red and green. Okay. Now, you might be thinking, I want a particular color. How am I going to work out what the numbers are? Well, actually, over here, there's a color picker. And just say I want a nice shade of maybe purple or pink. There's one there. So that shade of pink is 255 red, 61 green, and 194 blue. So I'm going to do that here. That's 61 green and 194 blue. And my text color, and I might change the background to blue. So RGB, red, green, blue, 255 on the blue. And now I get a pink and blue display. Okay. Now the next thing that you can do is if you add a comma, it stays inside the bracket, but after your text message, if you add a comma and then this command that says scroll speed. So it's important that your message is here, and then if you're changing the color or the speed, you need a comma between each command. And if you don't put that in, then your code won't work, and you might need to just delete the line and start again copying what's on the sheet. Now, if I run this, you'll see that now the scroll speed is half a second. It's quite slow. And if I want to speed it up, I'm just going to put, instead of 0.5, I'm going to put in 0.05, which should make it nice and nippy. And there you go. And my message is flying across the screen. It just says hello at the moment. I'm going to say hello, aliens. Maybe if there's an alien passing by and looking in the window of the ISS, they could see my message. So that's the first part of the challenge completed. The basic is that you get some text out there, but we've added a few nice little features with the text color and the scroll speed here as well. Now, the next part is to get a reading from the humidity sensor. And if I go and look at the code, it's given to me here. Okay. I'm not going to spend too much time on this because this is a pretty advanced piece of code. But basically, sense.getHumidity is a command that goes and reads the sensor and gets a humidity value. And then it just rounds it off so that it's a nice even number. And then it stores it in this humidity. It stores it here in this humidity. This is called a variable. Don't worry too much about it. It'll just work if you hit run. And we've got it 2 out of the 3. And now let's see when our program finishes. I've got 3 out of 3. Now I could submit the program now, but I'm taking a reading from the humidity sensor, but I'm not actually seeing what the reading is. So it would be nice before I submit it to be able to display the reading. And we're given a line of code that does just that here. So I'm going to copy and paste this. And what it's going to do, and this is quite a bit complicated as well, so we're not going to go too much into it other than it will give us the humidity and hit run. And I'm actually going to stop that because the humidity reading is going to be quite slow. So I'm just going to copy this and drop in another scroll speed here just to make the humidity reading fly across nice and fast as well. And I could change this message from relative humidity to something a bit short. And you see it's reading 49, thereabouts, which is around what the sensor slider is on here. Okay, so it took 12 seconds to run my code. I've got a bit of text out there. I'm reading a humidity and I am showing it on the display. You don't need to understand all of this code. You just need to be able to get it all together and get it running. And then I'm going to submit by putting in good car and hit continue to form. And you'll see that I have to put in a team name. So team power, I'm going to put in there, and I'm going to put in first name. Um, I can put in my name here, but I have to say I'm under a certain age or it won't work. So you have to be under 19, male, and then submit team information. And all going well. My program is now headed into space to be run on the ISS in May, and then my certificate will be issued in June. So I hope you enjoy this activity, and I think it's very exciting, and I'm excited even that bit of code that I've just run there is actually going to run in space on the ISS, and up there in space, my message, whatever I type in there, will come out on the ISS. So I hope you enjoyed this activity, and if you have any questions, please let me know.